Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean. DigitalOcean is the simplest cloud platform for developers and teams with products like Droplets, Spaces, Kubernetes, load balancers, block storage, and pre-built one-click apps. You can deploy, manage, and scale cloud applications faster and more efficiently on DigitalOcean. Whether you're running one virtual machine or 10,000, DigitalOcean makes managing your infrastructure way too easy. Get started for free with a $100 credit. Head to do.co/changelog. Again, do.co/changelog. Welcome to Go Time, a podcast featuring a diverse panel and special guests discussing cloud infrastructure, distributed systems, microservices, Kubernetes, Docker, and also Go. We record live every Tuesday at 3 p.m. Eastern, noon Pacific. Join the community that's live with us in real time during the show in the Go Time FM channel and Go for Slack. Follow us on Twitter. We're at GoTimeFM. Listen live at changelog.com/live or subscribe at changelog.com/GoTime. And now on to the show.
Okay, so welcome to Go Time. I'm Mat Ryer. Today we're going to be talking about APIs, the good, the bad, and the ugly. We're going to look at what makes a good API and what are some challenges for those of us building APIs. And what about any sort of common things we might want to avoid or gotchas to look out for. We'll have it all today. But let me tell you this morning on my walk, I passed a canal, and in that canal, there was a bag full of I didn't know what it was. I opened it up. 3 lovely gophers in there. I took them home. I've nurtured them back to health, and they joined me today. I'm joined by Mark Bates, Jaana B, Dogan, and Johnny Boursiquot.
Have you been drinking?
Hello.
I know it's late in the evening over there now, but
exactly. If we did this show would be completely different if we did it at a different time.
Right.
So before we get started, I think we should talk about what we mean by an API. Because there's lots of things, anything really is an API where there's machines speaking, but we're going to have to narrow the scope a little bit. And I propose we talk about, particularly in Go, so packages and what's exported from a package. For anybody that doesn't know about Go, perhaps you're new to Go, you use a capital letter on the names of things to export it from the package. And if it's exported, it means it can be seen from the outside. So it becomes part of the API. And also, when I talked about this on Twitter earlier, a lot of people were talking about web APIs. And web APIs are a very common form of API. So I think we can also include those too if they come up. And I'm sure they will. But let me go to Johnny first. Johnny, tell me, what makes a good API, do you think?
Ooh, well, there are lots of ways to answer that, depending on basically who the stakeholder is. But if we're talking as a consumer of an API, typically what I look for is basically a clarity of purpose, right? Is this thing doing what I expect it to do? How I expect it to do it? I'm also looking for usage documentation, not just endpoints, in the case of a web API, not just endpoints, inputs and outputs, but really like how do I make use of this if I'm new to the domain and maybe I'm just wrapping my head around what it is that I can do with this thing. What can I see as usage documentation, examples of how this API is utilized? And lastly, I like a stable API, right? But both from a functionality standpoint, right? I don't want, once I've integrated the API into my wares for it to be changing under my feet. But I'm also looking for stability in the operation of the API, right? How stable is it? Is it gonna be, if it's an external API, do I need to basically put safeguards in place for if it goes down or something like that? So there are different ways to look, or rather different elements that make a good and reliable and stable API.
And so if you're looking at a Go package that you're going to use in a project, what sort of things do you care about when you look at that package? Is it the same sorts of things around? It has to be very clear how I'm going to use it.
Mm-hmm.
Same kind of thing.
Same kind of thing. Clarity, again, usage, having some examples, and the Go standard library has a lot of good examples on how to use things. If you look at the funct package, for example, and for those new to Go, that's the FMT package. You'll see lots of examples of how to use the exported functions. Although in some cases, there are some functions that I talk about. So basically, for example, you might see a mention of, well, this is how you might use the formatting verb. This is just like, C. Well, if you don't know C, that may sound a little weird. That's some assumptions that the creators of the language have made, that you're coming from a background perhaps of C, but don't let that scare you away. But there are some good examples and good usage, sort of how to make use of those APIs in there. And also the same concern for stability, which is one of the things I love about the Go ethos, is that we don't really change things that you've come to rely on. When you build production grade software with the Go standard library, things are not going to shift right under your feet with the next update or the next upgrade of the language. That's a backward compatibility promise. Now we might see some things change in the next version of Go, but all these same elements, that clarity, that usage, and that stability, all these are things that are core to the Go community and how we build packages, I think.
Yeah, it's funny, isn't it? Backwards compatibility, the Go promise of, they say that anything that worked and compiled in V1 will continue to work. That really helps people invest in the technology, I think. But it's actually, from a design point of view, it's a very difficult thing to do, because sometimes as you're designing an API, usually at the beginning you have the least information about it. You're sort of imagining what this is going to be. And so it's a challenge, isn't it, as for those of building APIs, to think of, we want this to be this for a long time so that people can depend on it. That's definitely was a primary concern of ours when we were building Machinebox. We didn't want these things to just break with every major version, because that's just a pain for developers.
Yeah, especially if you don't know much about the domain. And as an API designer, I think you also learn more about the domain as you design more. And you always feel like you are behind. You always feel like if you start from scratch, you will be able to, come up with a better design. And it's like the most challenging part of API design. Do you have like any particular approach to achieve a stable API? For example, for me, it's more like starting with something alpha or version 0, running some experiments, making sure that I actually have like real users, and then, listening feedback, iterating a bit, and then trying to like cut more of like a stable API and try to freeze the API entirely so anybody can depend on it. Do you have any particular, process in terms of, figuring out what the stable API is going to look like?
Yeah, so for me and David Hernandez was my partner at Machinebox. We basically we got obsessed with taking features out and only delivering the so simple API. So simple that people think it's not enough. That was the idea. So we wanted people to look at the API and think, well, this is almost like a beta API anyway. And so we got obsessed with that, of just stripping everything out and only having the very core things. That's one way to do it. And then another trick we've used, which works, is to always have the tests around for the version 1. And you could even have them literally physically somewhere else as well, so that you have a test suite that protected your version 1 API. As long as all those tests still pass, provided they were what described the API in the first place, then you haven't broken it and code will continue to work.
Is it also the behavior-wise providing some compatibility because you're testing things, right? I think the hardest part of API design is also providing some compatibility, in terms of behavior as well. I mean, we just feel like we are more flexible in terms of breaking APIs, but breaking behavior. But in the end of the day, it's also like the most challenging parts of design, not to break the behavior for a long time. Yeah,
I suppose it's the common problem of you do have to do some design in the beginning, but that's almost the worst time to do it. Mm-hmm. Mark Bates.
Yeah, Mark has been quiet. I actually do have a follow-up question for you, Mark, especially because, obviously you have a framework that's becoming more and more popular, and a lot of people basically rely and depend on it. So you have to have good APIs. But before we get to that, the one thing, as we were talking just now, that sort of hit me is that we seem to have sort of a higher bar for APIs that we know are going to be exposed to the outside world than we do for APIs that are used internally, right, by our teams. It's almost like, I know for some of the teams I've worked on, is that basically when we know this API is not going to see the light of day, it's going to be internal, it's proprietary software, maybe it's something that is basically providing business value and it's proprietary. And you tend to be a little bit more lax on the documentation because you expect your team's just going to have to go in there, look at the code and figure out how this thing works, kind of thing, right? So these things I've sort of enumerated before as being sort of a key points or key aspects of a good API. It's almost like we don't look at those things, we don't apply those things as stringently on internal APIs. I'm wondering if anybody sort of on the call here feels like that's true for them as well.
I think it's true for everybody because we can make a bunch of assumptions when it's a private API. Right, you can look at it and say there's 4 people who are going to be using this, right? And you can have much stronger concrete types and do kind of different things than what you'd give to somebody who might have a very different business agenda than what your business does. And when they're private APIs, you don't feel so bad ripping them out and rebuilding them if you need to. Because again, you're only usually inconveniencing a few people. And even then, it's probably easy enough to fix in those situations. Public APIs are a very different beast, I think.
Mark, what version is Buffalo currently at?
0.14.2, and I think we're releasing .3 tomorrow.
And how long has it been around?
It's been around for a couple years.
And what's interesting about that is it doesn't start with a 1. You haven't released version 1 of Buffalo yet.
Yeah, I don't think it's ready to be version 1 yet. I think in that particular case, I think there's still a lot of work that needs to be done in a bunch of places, not just in the library APIs, but just some of the features and compatibility with other systems that we want to make sure are in there. We're still trying to figure that out. Now, Google App Engine was a big one, but that's kind of gone away. So I think we just need more of a how-to guide to check that one off the list. But, the way I build my APIs, and I was having this conversation with somebody yesterday on Slack, is I actually think the best APIs are those consumed by the person writing them, like just constantly. They said to me, like somebody who dog foods their own stuff as much as you do. And I'm like, well, I wrote it because I needed it. So yeah, I'm going to dog food it. And by doing that, what happens is, you start working away those rough edges. And I think, as Matt said, he started with something really small. And that's usually how I do. I kind of do a combination of what JBD does and what Matt was talking about, which is I often just kind of play around, scrappy kind of files and hack away at something until I feel as though, okay, that I understand the domain now. A good example of that was a couple weeks I was talking about. I used JBD's MIDI package to write some transport controls for Logic. And there was a lot of hacking around just trying to figure out how to make it work, how to talk to Logic. And like once I kind of do that, then I can refactor that into something that's a lot more kind of user-friendly, serviceable, testable, that sort of stuff. I don't ever go straight for I'm going to design the perfect API because it never works. I don't think I've ever sat down and designed a perfect API. What I try to do is, like I said, I kind of try to understand the problem domain, know the problem I'm trying to solve. And then I try to write APIs that hit the kind of 80% use case. So you can do 80% of what you need to do in just a couple lines of code. But I'd like to make sure that you have all the underlying support to do that other 20%. But you're going to have to wire it up manually. And what I find is when I'm dog fooding, I'll have that 80%, but I'll see another thing now that becomes a thorn in my side because it's not as smooth a process. And that's when I wrap that in an API to make that a 1 or 2 liner and, just keep sanding those rough edges off.
So you've hit on something else there, which is that dog fooding is the process of trying to use the thing you're building so that you get familiar with what it is you're building. You're doing what's really even, I think, better than that, which is you're building the things you need. And that's my advice to anyone that wants to start to create a Go package or to do an open source project, is build something that you need, because trying to imagine something that someone else might need, it really doesn't matter how good at imagining software you are.
Yeah, it's like a business. I mean, you could sit down and brainstorm, I think there could be a business in this, Twitter for dogs. And it's like, well, does anybody actually need Twitter for dogs? And it's write what you know. It's the same thing for writing. You're always told, write what you know. And the same thing goes for software. Write what you know. Write the things you need. Find the holes that are in your life. Brian Kettleson always is commenting about my tooling. And it's because I'm writing tooling that I use every single day to solve a very specific problem, whether it be releasing stuff, packing stuff, web frameworks, whatever it is. I'm writing things that I need today, not some pie in the sky idea of what I'll need tomorrow. And if I hadn't taken that approach with Buffalo, I think it wouldn't have grown the way it's been growing. I think people would have looked at it and went, no, that's just like all the other imagined frameworks I've seen out there.
I think the biggest problem is bad design is coming from these like people who never uses their stuff because there's a developer product. So I personally work for developer products all through my entire life. And, I work for larger companies and we usually have like, hey, we're going to build this product. We just don't really understand what is going on. And we assume some of the like priorities and so on and design. And I ended up like seeing lots of engineers didn't really use whatever they are building because it's not like necessarily some requirements in their like, day-to-day lives. And since they are so clueless about like, what does the big picture look like, how usable it is and so on, you usually end up like having all these like big gaps, usability problems, design problems. It's like the most ideal that you actually build something that you need, but it's also hard to scale because at some point you need to like have a big team of like sometimes 5-10 people to maintain an infrastructure thing, and it becomes a job of its own to maintain that. And nobody like people primarily working on it is not using it, so it's sometimes challenging, but. Yeah.
It's always challenging. I know I see that all the time. You get PRs or issues in for people, people say, I need this thing and I need it to be done. And they the one I always feel bad is those who write a PR to solve a problem they have that is either A, solved already, or B, is not necessarily a problem that should be solved by whatever they're contributing to. And that, if they'd opened an issue earlier, they would have kind of gotten that feedback earlier. But it's hard when you're a package maintainer, an API maintainer. You really have to keep looking at every PR and kind of enhancement that comes into your project. You have to really look at it and say, how is this going to affect my users of this API? And, how are they going to work with it? Is it something that can be worked on and extended later? Is this API too strict? We see that a lot where, it's very one way and it's very hard coded to a particular type, for example, or whatever. And you have to make those decisions. And it's tough to tell somebody, who just did a bunch of work, sorry, but this doesn't kind of fit with the ethos of the package or the tool.
Probably it's the hardest to say, hey, this doesn't have to be in the core. Like it could be an extension. You can just like maintain it at somewhere else. It's kind of like a utility. Yeah. If I keep hearing that like, lots of people need the same type of utility, we usually end up like, merging it as a utility package or something. But I try to like have some resistance maybe in the first place, not to overpopulate the APIs, right? Like you just want to keep things a little bit core and then gradually, organically maybe grow things depending on what people want.
This episode is brought to you by StrongDM. StrongDM makes it easy for DevOps to enforce the controls InfoSec teams require, manage access to any database, server, in any environment. And in this segment, we're talking to Jim Mordko, VP of Engineering at Hearst. He's sharing how they're using StrongDM within their team of 90 plus engineers. It now takes them just 60 seconds to offboard a team member from a data source.
We have an engineering team of somewhere in the area of 80 or 90 engineers. Because we've got so many services and many databases and so many developers, we need a reasonable way to manage access to them. It was a somewhat painful and labor-intensive process. Our DevOps team would literally have to manage every one of the permissions for everybody who wanted access. So Strong DM has been a real godsend in that area for us. Requests for access to specific databases were pretty much manual. Now we've adopted Strong DM. It's something that you don't even know is there. Once it's installed, it just works. It's very simple. We've set up a multitude of data sources so that when somebody's onboarded, we just give them access to Strong DM. It's pretty simple. Our DevOps team, they have a very minimal effort required to enable each data source to be connected to Strong DM, and then installing the client software is it's very, very simple and straightforward. You can use whatever client you want to talk to the database, so there's really no training necessary.
All right, if your team can benefit from nearly instant onboarding and offboarding that's fully SOC 2 compliant, head to strongdm.com to learn more and request a free demo. Again, strongdm.com.
So, we were just talking about the main reason why I have said no to people who've sent in PRs has been because that functionality doesn't really belong, like we talked a little bit about in the last section. It doesn't quite belong there. And so one good rule is, if the user can easily just do this themselves, they probably should do it and leave your package, leave it without that. You know, if you can do this outside in userland, then at least initially, then that's what you should encourage. And if lots of people start to do that, then I would say it's a good candidate for being something potentially that the package solves. But how do you decide what belongs in a package or what in an API, what belongs there and what doesn't? Are there any rules, or is this more of an art?
I actually find it easier in the Go community because people really like to see a minimal API surface. And I think some other language communities have this culture of like, hey, let's have all this batteries included library around. Let's provide all the utilities, like all the convenience functions and so on. I think Go, just generally speaking, culturally speaking, is a little bit different. So people just do not react a lot, but it's really tough. My strategy is usually sometimes analyzing what is on GitHub and figuring out if people are wrapping it in a specific way, or just keep constantly, building some utility convenience functions. I try to propose that we should probably, edit to the core APIs, but it requires some time. I'm trying to not jump on that utility stuff early in the days. Maybe it takes for a small API, for example, I'm giving it some time, few months, watching how people are using the API, and then just come back and suggest some improvements.
So you actually look at real users that are using your API?
Yeah, and I try to actually talk to some of the users because not everything is on GitHub, or not everything is open source, or not everybody's, there's no you don't have much accessibility to all the code using your stuff. So I try to ping a few people if they have time or interested. Then they're usually giving me more of these are the high level use cases we have, and it would be so much easier if you can, just jump on these cases and make it more easy. That's the sort of feedback I'm looking for.
Yeah, I do the same thing, but with, I troll through the, issues on the projects, or blog posts, or Twitter comments, or Slack, or whatever. And just I might not respond to all of them, but just understanding how people are using the packages is super critical to understanding whether something needs to be added, taken away, or changed in your package.
I've also seen lots of good feedback coming from Stack Overflow. I sometimes would go through the questions and see what people are trying to achieve and what is there. We never mentioned, but a good API design is not just about having usable stuff. It's also designing an API that is hard to misuse, right? So if I'm seeing lots of misusage or confusion around some cases, that's what I would do, and go back and either make things clear or redesign, or just add some maybe new utilities to change the entry point of the API.
Right. Yeah. Same exact thing. And to harken back to what you said actually earlier, JBD, about an external package or plugin, I think that's a super important thing that don't think a lot of people think of. And Matt was kind of saying it too. If you can do it externally, you probably should. I know I do that a lot. I'll write a lot of third-party packages for my own stuff as a way of just trying something out and seeing if it's even a tool that I want or need. If it, I'll have a problem, I'll go, let me write a small package that I can maybe has some middleware or whatever it is I need for my app and try it. And if it's good, then I can publish it. If it's not, I can rebuild it and try to understand. And I would love to see more people do that with, the packages they're using, try to build the extensions outside of the actual core of whatever package they're trying to use. Because most of the time that stuff can be kind of a singular focus where just that company really needs that piece, and they can still publish the open source part of it if they want to. But it's a great way to try to figure out whether that even needs to be in the, DHH does this with Rails a lot. He writes gems for features that he thinks might end up in Rails later. Of course, he just ends up pushing them all into Rails regardless. But I like that approach of let me try this as a plugin or an extension or a third-party package that sits on top of it all. And maybe I use embedding or something like that to enhance those APIs that I'm trying to wrap. But it's just a nice way of understanding what the process and not cluttering your main API.
And TDD really helps in Go with that. You can even put the test code in a different package. And if you do that, i.e. just a different package name, but in the same folder. If you do that, you then have to access your package using the dot notation and importing your package as you would. So it's very easy. It's a good way to catch any kind of stuttering in the naming. Like you might have brewer.brewT, when really that's kind of redundant. You could just have brewer.t. But of course, when you're designing the package, you think, oh, this package is going to brew tea, so the function is going to be called brew tea. That totally makes sense. So, but having the test code externally, that's quite a nice little trick just to get an idea of the API footprint that you're creating and get an idea of that design from the beginning.
Well, your tests tell you so much about your code too. Like if you can't test it, if you're struggling to test that 80% use case, which for me is kind of like my thing, right? I 80% of the time it should just be a few lines. It's super easy to do. If I can't test that easily, then there's a problem with that API. Because if I can't test it and I'm the designer of the API, then people using it can't test either.
Yeah, like I think that's a design approach that we've been using for a long time. We would just design the API surface without implementing anything and then write a test, an example like test, like there's no behavior. And people on the pull request would just, talk about the design. Since they have like some concrete usage example, we would kind of like find consensus on that minimal, API work and then, kept working on the rest of the stuff. Like this is basically how I bootstrap new packages. Just designing the API surface, just showing the snippet. It's a good protocol to,
Yeah, I do that with I'll take a scrap file and just start coding up what I think might be the way I want to interact with my software. And that's just stub methods or just code that doesn't even compile. Just this is how I think I want to approach this problem and think about it and rationalize it without any real code behind it.
Yeah, that's how I do it, but I do that with tests. And now, but I don't. It's the same spirit though. It's not meant. These tests aren't going to stick around. I'm exploring, but it is such a nice way. Like you're just being the user. It's kind of it's what we've all talked about. We've all mentioned it, which is know your audience and build for a purpose. And that this all just helps with that for sure.
So one set of things I think are in a lot of ways they're pronounced, right? The need for them are more pronounced with internal teams and software that doesn't end up, being open source and basically being subjected, to that kind of level, that level of feedback that we've all been talking about. When you're an internal team, you still have to sort of factor in a lot of these sort of good practices that we've been sort of talking about. But I think from my experience, what I've seen is that when you are tasked with developing an API for internal consumption, it's so easy to sort of to basically start throwing the kitchen sink at it, right? This is all the things that might be needed. You start basically, you're given a spec and you know what it is you're supposed to build, but that too requires some sort of iteration. That too requires that you do some README driven development. Sure, you share that with the team, get some feedback on that. But I think the one way to always ensure that you're never exposing too much, right? Because once it's out there, it's hard to take it back. One way to make sure that you're never exposing too much is to make judicious use of the internal package, right? So basically keeping as much internal as possible before you start exposing things basically in the rest of your package, because you have a lot more flexibility, in being able to sort of refactor things inside of that internal package. And then for those who are new to Go, basically the Go toolchain understands that pretty much, if you have an internal folder and you have, packages in there, anything in there basically is allowed to reference other things that are in there. But, if you're importing that package, you cannot, as a user of that package, you cannot get access to the things that are in internal. So basically using that mechanism, and this is something I wish I saw more in open source code out there, basically keeping as much hidden from external consumption as possible until you're ready and you're sure that whatever it is you're going to expose is indeed needed and is going to be relied upon.
I had this crazy idea that we should always start with internal packages and everything should be internally, and then we should replicate some parts like in the public API.
Yeah.
It kind of like, it's just organization-wise, I think it's also kind of like giving you some more flexibility to repeat the API, but, it's a little bit too much probably. But I really like the idea to put, a lot of things in internal and be very careful about what you're exposing.
I like to start with almost all private, non-exported things and then turn them on as I need to. Like when I'm trying to write tests, maybe through like a black box test and go, okay, I obviously need an entry point here. Let me expose the entry point now. Let me expose this thing that I need, obviously, when I'm writing my test, and figuring out those things as I go and try to see how much of it I can keep unexported. Because like Johnny said, I can turn those on later if needed, but what I can't do is turn them off later. Not easily anyway.
Yeah, so that's the key lesson then is you don't want to reveal too much. You don't want to commit to too much. If you care about backwards compatibility, that's more for you to maintain. So that's another reason why keeping the footprints as small as possible pays dividends later. The other one, of course, is, Johnny, that you mentioned right at the beginning of the show, clarity. If there's a lot to read, it just takes you longer to read it. I mean, that's just maths. It's just time, what was it? I've forgotten it.
Tragedy plus comedy equals time. Is that the saying?
That's a lot of my code. A lot of my code follows that pattern.
Tragic code.
That's what he meant by TDD, tragedy-driven development.
Wow.
And another interesting story, Jaana, you mentioned how things could potentially be misused. It is also part of designing it is also realizing that developers are sneaky little so-and-sos, and they will do anything they can to make something work. We know because we're them as well.
Totally. It's your responsibility sort of to restrict them, right? Like you need to give them the right API service, so you limit them in a way that makes sense. You just want them to be productive and not like, having to go like look for like hackarounds and that type of stuff, or like accessing too much maybe, more than you promised.
Yeah, one real life example I have of this is we had an API and there was an ID, and the ID field happened to be prefixed with the Unix time. So it was an ID, but it was also, you could, if you knew about that, if you noticed it, you could pull the time out and then you knew the time that something was created. And so people were doing that. And it wasn't part of the spec. The field was called ID. It didn't say it's got the time in it to help yourself. And so, it got abused. It got misused. And then it becomes a problem.
Yeah, I have this rule. Whatever you put out, it's going to be, abused. So you should better keep it really small, right?
You know what I love? I don't know if it's changing the subject or not, but, we're talking about APIs. And one of the things, not just the footprint, I like to see consistencies across APIs too. And anybody who's ever used my stuff knows that I tend to name things similarly. I tend to have the same patterns, the same ways of kind of interacting with code. And it's not because I just really like those styles. It's because I think consistency is important. That if you pick up these packages, they feel comfortable, familiar, and kind of easy to use if you know, say, the companion package.
Yeah, and I've seen this mistake sometimes, like people over time figure out better ways to do things. And for example, within the same package family, they would just switch to this new style just because they know that it's better. But it's definitely not worth it, right? Like you just want to be consistent. User just, understands this pattern. Let's keep using it, even though it might not be the most ideal one.
Yeah, it might not be the perfect pattern, but at least it's consistent.
Yeah.
The longer a project tends to go on, the more opportunities for such changes come up, and you have to work really, really hard, resist the urge to change things sort of, midway, unless you have the time and resources to go back and make it all the same. But again, once it's out there, trying to change it, it becomes extremely difficult.
Yeah, you see that a lot with, web APIs in particular, legacy, especially legacy ones, where half your API is in XML and the other half's in JSON. And now they've got a new protobuf one on top. And I'm not knocking XML or JSON or protobuf. I'm just saying, like, over years, I've seen this happen. I have dealt with many of APIs where this particular API set is XML and the other half of it that I need to use to build whatever is a JSON, and it's like now I've got to work in these two different worlds, or they're completely different styles. One's more of an RPC, and then they decided to move towards REST. And so you have to interact with them in very different ways.
Sometimes it's the maintainer. Maintainer changes and like their, personal style takes over.
Right.
I can easily tell like sometimes like, style differences, for example, between Brett Fitzpatrick and Ross Cox. Like I don't have to blame. Sometimes to be able to tell, like they have like different mental models. So you can tell, the style from the maintainer, and if someone new takes over the entire project, sometimes you see like the new packages are not super consistent because the style is different.
Yeah. Personally, if I develop a new style or feel that what I'm working with, is one way of doing it, but now there's a better way, or, things have changed in terms of usage and the way they need to work, I'll either do the major bump or create a whole new kind of package. And, I don't want to inconvenience people who are still reliant on that package just because maybe I don't like it anymore, the way it's laid out or designed or whatever. It's like, well, let's try to migrate you to a better written package. And that happened with me with Packer, where I moved from V1 to V2, and the V2 API is almost identical to the V1, but with a lot under the hood that changed quite dramatically. And there are a lot of changes, even in the public API, but I tried to make it as smooth a process to go from one package to another. Unfortunately, I think Go modules makes it slightly difficult to do the major revs right now anyway. But that's for a whole host of other reasons we're not going to get into today.
Why, you don't like /V2 in your package path?
We're not going to go into this today.
Okay, I was trolling, sorry.
I know you were, and I'm not biting. Follow my Twitter feed if you want my real feelings on anything, really.
What's your name on Twitter, Mark?
It's Mat Ryer. That's with one Y and one T.
I want to get verified if you're trying to spoof my account. But actually, Mark, you made an interesting point. You talk about if you want to change something, you have to do a sort of it has to be a major revision, because if you're keeping the backwards compatibility, you don't want to break things. That's another argument for having smaller and simpler APIs. It's easier to rewrite. It sounds silly, but it's actually a very sensible and pragmatic reason, I think, why you would select against adding some features. It's for the simplicity.
Absolutely. We're working towards moving a lot of stuff out of Buffalo and into plugins for that exact reason. Trying to slim down core to be just what it needs to be. And then you pull in the things you want on top of that. We shouldn't be no API should really be forcing a whole bunch of stuff on you that you don't want.
Yeah, another way to do that in Go is to look for the narrowest interfaces as well. So this is just a very practical thing that I've talked about a couple of times with some friends. I made a mistake once where I built an API and it was going to read from a file and process the file and return some object. So the input was os.file because that's what I was doing. I was opening a file. Now, that's fine, and in my case it worked. But then when I wanted to support web, I either had to break the API or create a file, like save the request body as a file so I could then use os.file. Well, if I'd just instead used IOReader, which is a much smaller type, it just has a single method interface. If I'd used that instead, it would have still taken the file, but it would also take the request body, that's a reader. It can take in-memory strings, it could take buffers, anything. So narrower types for interfaces, I think, is a good practical piece of advice for Gophers.
Yeah, I really like Dave Cheney's, typical advice on this. Like the input needs to be as flexible as possible, and it's better if it's a small interface. But the return type must be a concrete thing because it can be more expressive. So you're providing that flexibility by making the input types a small interface.
Yeah, it's a great way to think about it. And it also highlights the fact that it's very common for us to want to return interfaces because we're optimistic about how this is going to be used in the future. And also for testing, sometimes you think, I'll return an interface and then we can build a mock version or something else later. But you really don't need to do it. If a user of your API needs an interface, they can just write their own. And probably it'll be more relevant, it'll be more specific, and it'll have the context in their world.
I don't know if I agree with that
Yeah.
always. I agree with it in principle most of the time. But I do think there are definitely valid cases for returning interfaces. Packer is a great example where the file might be on disk, it might be in memory, it might be in a database, might be on S3. So when you ask Packer for a file, we have to give you an interface because we really don't know where that's coming from. And that's the easiest way of solving that problem is to use an interface.
Yeah. Well, I mean, like anything, I feel like there is no piece of advice that fits 100% of the time.
Right. No, I think it's a good 80-20 rule. Returning concrete types is a very good thing to do. And I'm not saying it's not. I'm just saying, being devil's advocate and saying there are definitely situations where the interface return makes so much more sense than the other way around. But most of the time, I would agree, yeah.
Yeah, but that's a great kind of discussion to have. I've been doing a lot of code reviews lately, just over the last week, and a lot of it's been about that. It's been about figuring out whether you've got the design right, really, and then having that discussion around that. And like Jaana mentioned earlier, discussing that stuff around interfaces is very easy because there's kind of less ambiguity around it, right? And seeing code is also less ambiguous than even READMEs.
And talking about interfaces, somebody gave me this advice a while ago that, try to not introduce a lot of interfaces in Go. Try to utilize what is in the standard library. And I think lots of people took that advice. And that's why there's not a lot of fragmentation going on in the library space. You can see that everybody embraced IO Reader, right? Everything works against those core APIs. So I really like about that. In Go, I think I like it because we don't have much fragmentation, because the interfaces are small, and we had this, initial culture of not introducing new interfaces, but utilizing what is already there.
This episode is brought to you by our friends at Rollbar. Move fast and fix things like we do here at Changelog. Check them out at rollbar.com/changelog. Resolve your errors in minutes and deploy with confidence. Catch your errors in your software before your users do. And if you're not using Rollbar yet or you haven't tried it yet, they want to give you $100 to donate to open source via Open Collective. And all you got to do is go to rollbar.com/changelog, sign up, integrate Rollbar into your app. And once you do that, they'll give you $100 to donate to open source. Once again, rollbar.com/changelog.
So why don't we talk in this last section a bit more about web APIs? I mean, HTTP isn't going anywhere, I don't think. And still, most people, I think, in Go are writing web services like this, like HTTP APIs and things. So does all this same thinking apply? I feel like it does. Is there anything specific we know about web APIs that we should talk about? One example is, for backwards compatibility, JSON actually ends up being quite a nice format because you can add fields to it without breaking most of the unmarshallers. And if an unmarshaller for JSON, by default, the Go one in particular, if it sees fields that it doesn't recognize or that aren't in the struct that it's trying to decode into, then they're just ignored by default. So JSON's actually quite a nice language for this, but really you trade off some type safety a little bit, but you can at least provide.
That's what I was going to say. JSON is a great format, but the type safety and issues you run into it sometimes are, especially in a heavily typed language like Go. Ruby, it was always fine. We never really had those problems, obviously, because there was no types. But in Go, I saw a ticket the other day where someone tried to enhance an int implementation by using parse float because they were getting a float into an int type. And it's like, well, don't send a float on an int type. But you can do that in JSON. So it's easy to put bad data in your JSON. That's kind of the problem I have with it.
In that particular case, it's okay because the float type in JSON is okay because it's a more broad type than the int. But when you can send a string...
Yeah, but it was the other way around. It was coming into Go. They were trying to get it into an int in Go. A float. Like they in their database it was an int type, but they were accepting floats from their JSON, and they were trying, and it was like, well, why don't you not accept floats? Don't send floats, just send ints if you need ints. Reject it right away and say this is bad data. You've got to work with the JSON more because of that.
I'd rather it was strict up front rather than create problems later, because that's the temptation with anything schemaless, I think, is we feel like, oh, well, we don't have to solve these problems. We can just accept anything and we'll just stick it into Mongo or stick it into a schemaless data store. But what you really do is just move the problem to later. You still have that problem of knowing what the data is and what to do with it.
And again, in a language that, a dynamic language like a Ruby or a Python where you can get away with that a lot easier, it's fine and almost welcome in a lot of ways there. But in a type-safe language like Go, or trying to get stuff into a database from JSON, there's definitely a lot of hand-holding you've got to be aware of and things you got to watch out for when you're accepting those payloads.
Yeah, it's actually rude in Ruby to return the same data twice, considered rude.
I don't even know what that means.
So in fairness, basically those who are sort of JSON proponents they did sort of mention, or rather they were excited about JSON schema, which I believe is a project that's still out there, and I'm not sure how often it's used. I think I've used it maybe once or twice a few years ago. It did try to basically provide some sort of structure, right? Some sort of expectation, basically, that when your data came in, you could perform some validation based on the schema and what you expected and didn't expect. So there was an attempt to basically have some structure around it.
Well, that's what tools like Swagger kind of purport to do, right? I think the problem I have more, and not that I hate JSON, I use JSON all the time. It's, again, that the language or the notation, and really in this case, it doesn't support the typing right out of the box, in that strict enforcement, where you have to do it yourself. You're bringing a third-party layer that sits on top of your app. But there's something the developer has to actively work on to make sure that data is sane when it comes in.
Yeah.
So then is it protobuf for everybody, or like how do we...
I don't have an answer. No, absolutely not. I don't have an answer. I'm just, a problem that comes up often for me when I'm working with web, writing JSON APIs is garbage data coming in. And not garbage, but, it's JSON. You can really shove anything you want. The NaN comes in. And how do you deal with NaN? Like that sort of stuff that, again, not making any language, but it's happened to all of us. If I could see you and ask you to raise your hand, you'd probably all raise your hand because you've gotten the NaN come through, right? It just happens. And that's just kind of a downside of a wildly unstructured language, or notation, rather.
That's an especially exciting thing for me to learn, because Nan here in England means like grandmother. So brilliant to hear you complaining about that, Mark. You mentioned Swagger. You see, Swagger, it takes some definition and it generates. It's a big code gen thing. The problem is what it generates is fugly, for want of a better term, or for the editors if they prefer me to not say that.
That might be an accurate term, yeah. That might be accurate.
It is, yeah.
What gets generated is not very attractive, and as a developer, that's the thing. I think whoever designed the outputs for Swagger, they're thinking of APIs as machine interfaces, because ultimately in production they are. It has to be a human that implements it first, and that's your first customer. So I think APIs should be written for humans. They're not really for machines.
Well, maybe. No, I mean, there are legitimate cases, again, definitely taking into account what you said earlier, Matt, about basically, the rule is not universal. But yeah, I mean, there are some cases where you have machine generated APIs and you have, other machines consuming these APIs based on some predefined spec, it does happen. But yeah, generally speaking, I think you're writing APIs to be consumed by other humans that are going to be reading and trying to figure out what it is, how it is you want them to use your API. So yeah, it should be readable above else, which is, again, that extends into sort of the Go ethos, right? Readability over clever tricks and obfuscated things. So basically just trying to make it as clear as possible to actually use.
Yeah, almost boring, right? You don't have to be creative in that API design. It, like Mark said, when he was talking about earlier about being consistent within a project, that also applies across the whole community. And there are kind of patterns, I think, that have emerged that we sort of all like and we've all kind of rallied around. And they won't be unchanging, like they won't make it into the spec or anything. But that as a part, it becomes part of the culture, and it is around simplicity, like what's new monkey gonna do when I call zoo.newMonkey? So I think there's clues, aren't there, that we can leave, and also, again, simplicity. If your goal is to make it as simple as possible, I think that helps on all of these axes.
Well, can I ask a question to the group? Because I'm actually very curious to hear this answer, because I think web APIs are a very different beast than, programmatic package APIs, right? They're consumed wildly different. They're used wildly different. And this is something I try to struggle. I talked about the 80-20 rule earlier, where I try to make my packages work in a way that, 80% of the time it's a couple lines and you're done. But the other 20, you can really dig deep into it and do whatever it is you need to do much more manually. How does that translate to web APIs? Do we give everybody a one-to-one REST API, table to REST? Do we do an 80% API that does most of the common functions with one call, and still offer that almost one-to-one table to REST API? I mean, what are people's opinions on that?
I personally, given a choice, I would go for sort of small pieces that I can easily compose, because as a consumer, you, the producer, may not know how I'm going to be using your API, unless it's a strictly sort of a bounded context where there's only certain things that are clearly defined that you can and can't do. But for things that are sort of a bit looser, where you don't quite know how an API is going to be used, give me the small bits and I'll compose them together into what I need. That said, this goes squarely against the whole basically only expose just what you need kind of thing. But I think there's a balance there, right? There's a, like we've been saying, there's an 80-20 there that you kind of have to watch out for. And that's something that I think comes with experience and the problem you're trying to solve, the domain you're in, and what your users expect.
So let me actually give a concrete, or a fairly concrete one that I think we can all probably wrap our heads around. So let's imagine a music service, right? And so you have albums, you have artists, and you have songs. Okay. Obviously, an album belongs to an artist and has many songs. An artist has many albums and also has many songs, and so on and so forth. What kind of an API would we build where maybe I want to ask this API for an album, and I want to obviously build a nice page around it that has the artist, that has the songs. Do I make 3 requests to each REST endpoint saying, get me this particular album, now go to this other API, get me this artist, now go to this other API, get me this songs? Do I expose those 3 and a 4th, which is kind of like get the whole album, get the album info, which pulls down all that data? Do I expose that?
No. What you do,
like, how do we do about that?
I'll tell you exactly how you do that.
Right? It's a tricky question, because it's an important design decision. Like, we're talking, that's the 80 rule, right? Like 80% of the time you want to display the album and the artist and the songs, right?
But sometimes you might not, right? So which is why I love, things like GraphQL, for example, which gives you the flexibility to be able to ask for some things and not others, because, sometimes you just want some things and not others, right? So rather than you trying to guess ahead of time what the common usage pattern is going to be,
right,
you provide the flexibility for somebody to ask just for what they want.
That's great. Can you write all my GraphQL APIs, please?
Sure.
Sure. I'm going to take you up on that.
So now, Mark, that's your technical support for free. It's good work there.
Fabulous.
No, it's a good point.
No, I was trying to use an example. I think it's a tough thing to ask because, I mean, you overload people. They have to keep making 100 API calls to build one page. Or do you give them that flexibility and also give them the 80% API where they only have to make a couple API calls to build the same type of page?
Yeah, and I think it comes back to knowing your customer and knowing your audience, because it depends on what they want to build. They might well want to build the more granulated experience, or perhaps it's just they're doing things that you didn't even dream of in that API, which is more likely to be the case, and probably things you don't approve of if you've given me an API key.
Or you don't want them to like scrape your entire data set or something, right?
Right. But see, there you go. That's another valuable piece of information when you're building an API. How much information do you give away in your API is another great point, JBD.
Yeah, and the answer I think is, again, as little as possible, because you protect from all kinds of different things. Not really about. I mean, I assume that people aren't going to go and. I just assume people aren't going to come and just steal the data. That's quite naive. I don't work in security. So other people do, and I thank them for it. But I would say you would almost defer that decision. Build whatever you need to make your thing work, and wait for there to be API customers if you can, because they're the ones that'll know how they need it, and that's then the good time to let the thing evolve and grow and be designed. But that's a great example, because I bet all of our listeners have had almost that exact kind of example before.
It's one of those things where you've got multiple data to really see a full picture of something. You need multiple inputs. And it's, how do you build an endpoint that consolidates those multiple endpoints, or do you give them those multiple endpoints and they have to consolidate?
And if you don't know anything about your users, you kind of have to do everything. That's the idea behind being obsessed with knowing who the user's going to be before you even do it. Yeah, because otherwise I think, you'd have to just do the most granular level, probably, if you don't know anything about the users. Good one, though.
Right. And roll up the common usage patterns later.
Yeah, because they'll either emerge, or you'll have people, if it's successful, people will be knocking on your door for it. But the other thing is as well, sometimes it's more efficient. Like sometimes we'll optimize for efficiency, but we will lose some clarity as well. And I think that has to come into it as well. You have to think about, it's an art form for sure, designing this stuff. That's why, it's a shame we can't just come on the podcast and say, here's a list of 10 things that you should do, and here's a list of 10 things you shouldn't do. It really isn't as simple as that, which is why we have jobs.
Me like jobs. I don't know about you.
Speak for yourself.
Yeah, Mark, what's your job now?
Is it time to wrap up?
I'm just asking what the job is.
My job is to help train the next generation of Go developers and to help bring more people into the Go community.
Hey, that's my line.
Yes, and Buffalo.
You like that? Yeah.
Johnny, where do you work, Johnny?
Myself, I kind of do similar things to what Mr. Bates over here mentioned, but I do have a day job where I work for a nonprofit, doing things that have a real meaningful impact on the life of students in underserved communities.
Oh, that sounds awesome. What's the name of it?
Yeah, they're called the Achievement Network.
Mm.
Yeah, and actually, now that we're talking about it, it is, they are, although I'm not going to mention them too much during my upcoming talk, they are, in part, the subject of my keynote that's happening for Gotham Go this week.
Oh, wow.
Oh.
So I do hope to see at least some of you at Gotham Go this year. It's an awesome conference. I always love going there every year.
I might be there.
Something about Mark, might be there.
I'll try to attend.
It is a great conference, though, for anyone in that area. Probably going to be too late by the time this goes out, but look for next year, Gotham Go. It's like a single track. You're all in one room, which I think is a great experience. You all get the same experience, and it's always a conference that has a great sense of humor. I love it.
It's probably the funnest conference I go to. It's like I just love it. It's because it's about 150 people. It's super small, and the audience is right there. The speakers are right there. We play games, we talk, we laugh, we joke. It's not uncommon to see some idiot dressed up as Batman or a Mexican wrestler on stage, right? You never know what's going to happen at Gotham Go. So I do think it is a fantastic little conference. No slight to all the other conferences, but it is one of my favorites.
I think your last year's performance about 2.0 features was amazing. Like, I've never seen anything like that, and like you were super self-conscious about it, but like it was amazing. I still have like recordings, and I still keep playing once in a while.
Evidence.
Yeah, I was kind of hoping that would fade into oblivion, but I don't think that's going to happen.
It's on the internet, man. You can't get rid of it.
Well, this year, I promise you it's going to be even better.
Oh, boy.
Ooh.
We've got some things planned that are going to really shake up the conference scene as we know it.
Wow.
Do you remember the first year?
I wasn't a host the first year. The first year was just Gray hosting. He's really the person who does all the hard work, Greg Herder, and I just want to give him a quick shout out because he runs a bunch of conferences, Capital Go and JS Nation and a few other things, and he just does so much hard work.
True.
For that conference. And then Steve and I usually get up there and do our shtick for the day, and everybody thanks us, and they really shouldn't. They should be thanking Gray and his family.
Indeed.
And he's got an awesome name as well. His name's Gray Herter, right?
Yeah. He's a great guy, and his family, it's a family operation. His wife and his mother-in-law sit at the front check-in desk, checking everybody in. It's so much fun. It's such a nice conference, such a great vibe.
Yeah. They're awesome people.
Well, I hope they're adequately paid. Cool. So I think then we've learned a lot today on our journey of discussing APIs. In particular, some things stood out. Clarity was something, Johnny, you mentioned very early as being an important thing. And I think you're right. You want an API as a developer. You want to be able to consume an API very quickly. You want to use the service, whatever it is you're going to use. You're really playing with it in the beginning. So you want to be able to play with it very easily, and that means it has to be simple and easy to implement. And of course, that minimalism also helps for maintaining that API. You've made fewer promises, so there's less you have to keep in the future, and it allows you to sort of change internals and things without disrupting people too much. And I think consistency as well, and being obvious. And if you're the same from an API point of view, if you're the same as other people, and the same, within your own set of services, that familiarity is going to really help when it comes to consuming those APIs too. So I think it's been an excellent show. I've learned a lot. Has everybody else learned a lot? Not just about things Mark said, but lots of things too.
No one learned anything from what I said. That's just a gimme.
JBD, you work at Google, don't you?
I do. It's a small shop.
Yep.
we use Go from time to time, right?
I've heard good things. I think they're growing. I'm impressed.
We're growing, yeah.
Small Mountain View startup. I think they've got some wings.
Go's hot on the tails, though.
Yeah, we're keeping it humble.
Yeah. So what is it you do? What's a typical day for you?
I work on some of our monitoring stack, some of the performance tools. My team is actually working both on internal and external products. We have lots of instrumentation libraries and debugging tools, and just more generally monitoring metric collection type of backends that we collaborate with internally. So our instrumentation library is linked in to every production binary at Google, so it's kind of a big part of the production experience. And we kind of help the teams to make sure that they are collecting right stuff. At the design time, they care about observability, and we give them suggestions and so on.
That's awesome. I think we will have to do a future show on that, and what we need to know as Gophers as we build our services too. I think it would be awesome. Well, that's our show for this week. We'll see you next week.
All right, Go Time is back. It's been so much work behind the scenes, but it's definitely paying off now. And it's so much fun producing this show. We have so many people listening live. Thank you so much for that. We love you. And if you're not yet, hang with us in Gopher Slack. We have a channel called Go Time FM. Look it up. You'll find us. Chat with the community, share stories, share coffee recipes, whatever. It's a lot of fun. Also, we have discussions on every single episode at changelog.com. So head to changelog.com/go-time, find this episode, and discuss it with the community. And of course, thank you to our sponsors, DigitalOcean, StrongDM, and Rollbar. Huge thanks to Fastly for being our bandwidth partner. Head to fastly.com to learn more. And we move fast and fix things around here at Changelog because of Rollbar. Check them out at rollbar.com/changelog. And we're hosted on Linode cloud servers. Head to linode.com/changelog. Our music is by the one and only Breakmaster Cylinder. And if you want to hear more episodes like this, subscribe to our master feed at changelog.com/master, or go to your podcast app and search for Changelog Master. You'll find it. Subscribe, get all of our shows in one single feed, as well as some extras that only hit the master feed. Thanks for listening. We'll see you soon. All right, because you've stuck in here to the end of the show, got a surprise for you. Here's another preview of our upcoming show called Brain Science. This podcast is for the curious. We explore the inner workings of the human brain to understand behavior change, habit formation, mental health, and the complexities of the human condition. It's hosted by myself, Adam Stacoviak, and my good friend Muriel Reese, a doctor in clinical psychology. It's about brain science applied, not just how the brain works, but how we apply what we know about the brain to better our lives. There we go.
That's why I always say in working with different patients about the importance to put your lid on. As a human, we put on our frontal lobe, which means I don't just go with whatever I feel. Even though they might be super powerful, I have to be able to think through and go, like, say, for example, you're cut off when you're driving, right? And you might want to do something rude or maybe aggressive, that your frontal lobe goes, whoa, slow down. I understand that emotion, but maybe that isn't the best choice of action. And I would say that's also really a function of something fundamental to our human brain, is that we get to make choices. Mammals don't really make choices. Reptiles don't really make choices. They just react. It's like, so I feel, there I do.
That's the sign of regret too. Sometimes you do something in that, from that perspective without thought and just reaction. And later on you're like, well, if I really had to be rational about that scenario, the person really wasn't trying to punch me in the face and I shouldn't have fought back because, I don't know, I'm being silly there, but, you get into scenarios where you're like, you have an argument on the internet, or, you get triggered on Twitter, or something happens where you just react. And, maybe if you had the prefrontal cortex come into place and give you a chance to rationally think about things, but we often just react. Why is that?
Because it's ironic, but we actually, generally speaking, we process information from the bottom up, which means we take in data from all of our senses and it comes up through the brainstem and then the mammal brain and then the human brain. So we
back
don't
to the hand being up, if someone's kind of still following along, they've got their wrist there. That wrist is, bottom up essentially. So elbow up to your wrist is, your elbow could be your body essentially, and your wrist is the beginning of your brainstem. And does that include your eyes, or your eyes going to the bottom of your brainstem first and then through the rest of things? Like when we think of, see, taste, touch, feel, whatever, all those different senses.
Yeah.
How do they connect to the brain?
Well, so it's always more complicated than what I'd like it to be, because, right, turtles, all these other animals have eyes, but the system works differently. So, for example, you've seen those, like when people touch objects and have to try to make sense of them as based on how they feel, right? That everybody's visual cortex is different as based on what they've been exposed to, right? So this comes back to individualized experiences. I mean, one person's view of poverty might be different than another person's, simply as based on what they've seen or been exposed to.
That's a preview of Brain Science. If you love where we're going with this, send us an email to get on the list to be notified the very moment this show gets released. Email us at editors@changelog.com. In the subject line, put in all caps Brain Science with a couple bangs if you're really excited. You can also subscribe to our master feed to get all of our shows in one single feed. Head to changelog.com/master or search in your podcast app for Changelog Master. You'll find it. Subscribe, get all of our shows, and even those that only hit the master feed. Again, changelog.com/master.